Okay, we're now looking at question 9 in exercise 14.6. Now, the only information we are given in this question is that we have triangle ABC, and we are told that AB equals AC, and we actually have to prove that angle ABC equals angle ACB. In other words, we have to prove that the base angles of an isosceles triangle are equal. Now, you can't just say that they're base angles and that they're equal. You actually have to prove it. And the way that we're going to do that is by using congruent triangles. So we first need to add a construction line. We're going to add a line straight down the middle, and it's actually going to be, we're going to bisect angle A at the top. Okay, so I'm going to call this line AD, and it goes from A down to the base D, and it's the bisector of angle A. So we're calling it AD. So what we do, we need to say that we've done that. So the first bit of our solution is to say construct AD, which is the angle bisector of angle A. Now, actually, let me just fix these up here. And I don't know why that's happening. It might be from the last one that I've just added. I should just move them up then. I might just group them together for a minute. Okay, so we've constructed AD. The first bit of information, so now we actually have two triangles, so we can actually say in triangle ABD and triangle ADC. So we really need to say that. So we say in triangle ABD and triangle ACD, we can say that AB equals AC, which is given. The next piece, so that's our first bit of information, that AB equals AC. Also, because we drew AD such that it is the bisector, angle bisector of angle BAC, we know that angle BAD equals angle CAD, and the reason is that AD bisects angle BAC. So we can write that in next. So angle BAD equals angle CAD because AD bisects angle BAC. We can also see in the two triangles that we've got, so far we've got a side. We've got these angles, little angles at the top. I might put in little symbols if I can find some. I'll put a little circle in there. Well, that's probably, oh, all right, I'll just move it a little bit. So that angle, I know that circle's a bit big, equals this angle up here. So we've got side, angle. We also can see that AD is common to both triangles, so we can now say that AD is a common side. So what we've got here, I'm going to just put some markings here. I'll just put a, oh, that's a bit big. I'll just put a double line there to show that this is the other side. So we've got side, angle, side. So these two triangles are congruent by side, angle, side. So we can just say now that triangle BAD is congruent to triangle CAD, and the reason is side, angle, and side. We're asked to prove that angle ABC equals angle ACB, and we've done that now because if these two triangles are congruent, we can see that this angle ABC is the matching or corresponding angle with angle ACB. So that's our last bit of this proof. So angle ABC equals angle ACB, reason being that they are matching or corresponding sides of congruent triangles. Now we can look at part B also in question 9. So this time we're told that we have triangle ABC, and we are actually told that angle ABC equals angle ACB. So we have base angles equal, and what we've been asked to do is to show or prove that we have to prove that AB equals AC. So this is the opposite, or what we call the converse, of what you were asked to do in part A of this question. Now, to prove that AB equals AC, again, we're going to use congruent triangles. But as you can see, again, we've only got one triangle. So what we need to do is to construct AD again, which is the bisector of angle A. So we'll bring AD in again. So we've got AD. And we actually need to tell, the marker that this is what you are doing. So we start with our solution and we say construct AD, which is the perpendicular bisector of sorry, not the perpendicular bisector, it's the bisector of angle A. Because we've just bisected angle A, we will therefore know that angle BAD equals angle CAD. So we can say that now. So we can say that, sorry, this keeps moving down. We know that angle BAD equals angle CAD. Now, because we've just said that those two angles are equal, we're going to mark those two angles in on the diagram. I'm just doing it with little crosses to show that those two angles are the same. This helps you keep track of what you've done so far in the question. So we can actually see that we've got these two dot sort of angles equal, and these two crosses mean that these two angles up here are equal. So far we've got angle and angle, and the last thing that, the only congruency proof with two angles is angle, angle, side. So let's see if we can find a side. We can see that AD is a common side. So that will be the next thing that we say, that AD is a common side. I'm just going to mark that in. You should mark it as well because it makes your working out and your proof very visual. So AD is the common side. So therefore we can now see that we've got our three pieces of information, that these two triangles are congruent. So we need to state the vertices in matching order. So A goes from this cross to B, which is the circle, to D, which is the other angle with nothing on it. And in matching order, we would have A with the cross, C with the circle angle, and D with the blank angle there. So we can say that triangle ABD is congruent to triangle ACD, and the reason is AAS. We now have to prove that AB is equal to AC. These are corresponding sides, because if you look at AB, it's the side that goes from the little X to the dot, and the AC is also the side that goes from the X to the dot. So therefore AB equals AC, and that is because they are matching sides of congruent triangles. And that is the end of question 9.